Chapter 3-2 continued. Substitution method. This is the third method that we're going to be finding or using to find the point of intersection. Okay? Substitution, very simple. Okay? If we're playing a sport, basketball, volleyball, softball, football, okay? Anything like that. A player goes off the field or out of the court, another player goes in for them, correct? Okay? Now, typically they don't have to go into the same position. But what we're doing today, mathematically, requires that they go in for exactly the same spot. You understand that? Now, substitution is a great method to use. However, it's a pain in the butt if you do not know how to deal with fractions. Okay? So what we generally like to do is use the substitution method when your coefficient of a variable is 1. If your coefficient of the variable is not 1, then it is not a very pretty method to use. Okay? Not a very pretty method to use. So we want to look for the coefficients. What's the coefficient again?
X and Y.
Those are your variables. X and Y are your variables. What's the coefficient?
The number
The number in front of the variable, correct? So coefficient is the number in front of the variable. If that number is 1, this is when we like to use substitution. Okay? Now, steps to doing substitution. Again, why does Yoder give you steps?
To make it easier.
So that whenever my sheepies get lost in the pasture, in the wilderness, when they're all alone by themselves, they can take out the steps and they can have a little light that guides them along the path, right?
Yes.
Okay. So, step 1, choose one equation and pick a variable with a coefficient of 1 if possible. If the coefficient is not 1, because you don't have a 1, then you just choose one of the lesser of the two evils and go with it. Sometimes there is no lesser evil, it's just all evil, and you just pick one of them. You get what I'm saying?
Mm-hmm.
Step 2, solve that equation for the variable you chose. Step 3, plug that expression into the other equation. We have two equations. We're choosing one equation, solving for a specified variable, taking that expression then, plugging it into the other equation every place you see it. Plug that value into the expression that you solved for previously, and then this is your POI. Now, there's a lot of steps going on there, but let's just go ahead and try to solve this. So the first example we have, 4x plus y is equal to 5, and x minus 2y is equal to 8. Look at equation 1. Do you have any coefficients that are 1?
The first Y.
The coefficient on the y is a 1. Do we understand that? Look at equation 2.
X.
The coefficient on the x is going to be a 1. So now what you need to decide is, do you want to take equation 1 and solve for y, or do you want to take equation 2 and solve for x? Which would you prefer?
Solve for Y.
Okay, so what we're going to do is we're going to be like Hansel and Gretel through the woods. We're going to leave our little breadcrumbs, and we're going to say equation 1, and we're going to say what we're going to do to equation 1, which is solve for y. Do we understand that? We're leaving our little breadcrumbs or our maps so we know exactly what we're doing. Okay? So we're taking equation 1, which is 4x plus y, is equal to 5, and what am I going to do with that? I'm going to subtract the 4x from both sides because I'm solving this thing for y. So y is equal to negative 4x plus 5. Box that in. When you box something in, it's one of two things. It's either the answer, or it means you need to come back to it because it's really important. Do we understand that? Now, we're looking for the point of intersection. Is this the answer, or is that something that's important?
Something that's important.
It's something that's important because clearly the point of intersection is going to be an ordered pair. That's not an ordered pair, that's an expression. You understand that? Okay, now, moving on. What have I not used so far? I used equation 1 and I solved it for y. Now, what have I not used?
Equation 2.
Equation 2. Well, we cannot ignore equation 2 just because you don't like it. We have to use equation 2. Now, if you look in your steps said to do what?
Plug that expression into the other equation.
It says plug that expression that you got in equation 1 into the second equation for that specified variable. Do we understand that? So equation 2, what we're going to do is PNC. Plug and chug. Do we all understand that? We're going to plug and chug. So equation 2 is going to be x minus 2y is equal to 8. And every place I see y, what am I going to plug in for it?
Negative 4x plus 5.
So I have x minus 2 times negative 4x plus 5 is equal to 8. Do we all see what I did up there, yes or no?
Yes.
The blue represents the new expression that I solved for previously in equation 1. We good?
Yes.
Perfection. Now what do I need to do?
Distribute.
I need to distribute. What's up? You're just gonna tell me? Okay. Distribute. So that gives me x plus 8x minus 10 is equal to 8. What's CLT? CLT. What do I do next?
Calculate. Yeah.
Combine like terms.
Combine like terms. X plus 8x is 9x. Now what do? Add 10 to both sides. 9x is equal to 18. Divide by 9. X is equal to 2. Now I box that in. Is that part of my answer? Or is
Yes.
that important information?
Important information.
It is part of my answer, is it not?
Yeah.
My POI is an x coordinate and a y coordinate. I'm telling you that x is equal to 2. Now how would I go about finding my y coordinate?
You'll plug the x equals 2 into one of the equations.
You can either go back to one of the original equations, or you can simply go back to your box, right? Because your box is solved for y, is it not?
Yes.
So if it's already solved for y, half the work's done for you. All I have to do is plug and shove the 2 in for x. So negative 4 times 2 gives me?
Negative 8.
Negative 8 plus 5 gives me? Negative 3. And this is my y value. So my question to you right now is this system a consistent system, meaning they intersect, or an inconsistent system, meaning they do not intersect?
They're consistent.
It's consistent because they do intersect. And is it an independent system, meaning it intersects at one point, or is it a dependent system, meaning it intersects at many points?
Independent.
It's independent. And I'm going to have one POI. And what is that point of intersection?
2, negative 3.
2, negative 3. Do we understand what I just did for you? Yes or no? Now, it's a beautiful method to use. I prefer elimination because elimination is all the way straight down the whole time, right? Very plain, not a whole lot of plugging and chugging. Substitution, you have to work with both of them and you have to plug back in anyway. It works, but when I don't like it is, for an example, like the next one. Why would I not like to do substitution on this problem?
Finally, coming multiple.
Because I don't have a coefficient of 1, okay? And Sammy's right. What you're going to notice is you immediately want to find your least common multiple, correct? Because I don't have a coefficient of 1. Now, does that mean I cannot do substitution?
You can, but you gotta get 1 equal.
I can do substitution, except for what's going to happen is I'm going to have fractional expressions, aren't I? So we're going to go ahead and we're going to solve this for one of our variables. Now, do we want to take equation 1, solving for either x or y, or equation 2 and solve for either x or y? What would you rather do? Equation 1 is what we're going to use. And you tell me, what are we going to solve for? Solve for x? Sure, we can do that. So 3x minus 2y is equal to 16. If I'm solving for x, what should I do? Add 2y to both sides. 3x is equal to 2y plus 16. Now, previously, when we were working with mx plus b, what did I do at this point?
Divide by.
We divided each term, didn't we? Now, what we're going to do is, instead of dividing by each term, we're going to divide both sides. That way, we're dealing with one fraction rather than possibly two fractions. Do we understand that?
Yes.
By dividing both sides by the value 3, we now are going to be dealing with one fraction rather than two fractions. Now, we're going to box this in. Why am I boxing that in again?
Because there'll be a point.
We're going to box that in because that is something that's important. I can go back to that after I solve my next equation to be able to plug and chug to find x, correct?
Correct.
So now I'm forced to use equation 2. And what do I do on equation 2?
Plug and chug.
Plug and chug. So equation 2 is 4x minus 3y is equal to 23. And every place that I see an x, what am I going to plug in?
2y plus 16
2y.
over 3.
4 times 2y plus 16 over 3 minus 3y is equal to 23. Now, what do you notice that we have? we have? We have a fraction, correct? Now, should we be freaking out, or should we be saying, hey, you know what? I was taught how to get rid of this and make it look pretty, right? So how do I make this thing look pretty?
This should be.
We're going to multiply the entire equation by my least common denominator, which is going to be the value of 3. Do we all understand that?
Yes.
Now, my question to you is how many terms do I have up there? 3. I have 3 terms. This is a term, this is a term, and this is a term. Do we all see that? Yes or no? Those are my 3 terms. Okay? So we're going to multiply this entire thing by 3. So what happens whenever I take 3 times that jump?
It'll become 4
The
times.
3's cancel out, and I drop down the 4 times the 2y plus the 16. Minus, now what do I do over here?
You'll do
9y is equal to, over here,
69.
69. What do you do now? Looks a lot
Distribute.
prettier, doesn't it? I'm going to go ahead and distribute. So that's going to give me 8y plus 4 times 16 gives me
42.
54. Wait, what? Hold on.
64. Okay, now what's 8y minus 9y? Negative 1y. Plus 64 is equal to 69.
Subtract 64.
Subtract 64. And that gives me negative y is equal to 5. Now what? Divide by negative 1. So y is equal to negative 5. Am I done?
No.
No, I found what y is. Now how do I find out what x is?
You gotta plug it back into an equation.
Go back to your original equations or go back to your box, correct? If you go back to your box, all you gotta do is simply plug and chug. So this gives you 2 times negative 5 plus 16 all over 3. What's 2 times negative 5?
Negative 10.
Plus 16 divided by 3? X is equal to 2. So now, my question is this consistent or inconsistent? Consistent means that they cross, and clearly they're going to cross. Is it independent or dependent? Independent, because why? Because there's only one point of intersection. What is my POI?
2 comma negative 5.
2 comma negative 5. We good? Now, if you look at the 2 problems I just showed you, when is this nicer to use?
When x or y, when one of the coefficients is 1.
It's a lot nicer to use substitution when your coefficient is 1, rather than when it is not. However, is it possible to do it whenever we have a fraction? Yes, it's just multiply by your LCD. Do we all understand this? Do I need to do another example, or do you feel like you got it? Okay. Tonight's homework is on your notes. It's problems 10 through 18. Now I want to bring your attention to problems 10 through 18. If you're looking at problems 10 through 18, that brings us right here. I said in the instructions that you can do either elimination or substitution. Directions state that you're supposed to use substitution. I'm giving you the option to use either or. Do you understand that? I'm telling you this because I want you guys to learn to justify when to use elimination and when to use substitution. Does that make sense? Okay? Now, if we look at number 10, which method is easier to use, either elimination or substitution?
Substitution.
Why would substitution be your go-to method here?
Because one side just has y.
Because, guys, it's already telling me that y is equal to 5x. Do we understand that? It's already telling you that. So you just take what y is in the first equation, substitute 5x for it, and you can solve for x then, yes? Look at number 11. Which method would you use on that? You're going to use substitution again. Look at number 12. I would use substitution on number 12. Look at number 13. Substitution is already solved for you. How about number 14? Could you do either or?
Yeah.
Yes, you could do either or simply because of the fact that that's a 1x there. So I could do elimination or I could do substitution. Okay? What about 15? Same exact thing. And 16?
Either or.
Substitution.
I do substitution because it's already solved for you. What about 17? Substitution already solved. What about 18?
Either or.
Either or because it's not. Do we all understand that? Now the problems with 10 through 18, are you going to have any fractional problems if you choose wisely for substitution?
Probably not.
Yes, you're only supposed to do these. I talked about all of them. Okay? You're not going to have any fractional expressions to plug in because the coefficients are what? The coefficients are 1, so you're okay. However, if you scroll down here for problems 37 through 42, the directions say solve each system by elimination. I changed the instructions, didn't I?
Make it harder.
I made it harder on you, and I'm telling you, you have to use substitution. Check this out for 37. There are absolutely no ones there, are there? So you're going to have a fractional expression there. Look at 38. No ones. You're going to have a fractional expression there. 39. Do you have ones there?
Yes.
So will you have a fractional expression there? No, you're okay. Look at 40.
We're doing it because
40 is going to be a cakewalk for you because it's already what?
Solve for
It's
y.
already solved for y. Look at 41. What did I multiply 3 by to get 6?
2.
What did I multiply 2 by to get 4?
2.
What did I multiply 10 by to get 15? Not 2. So what does that tell you? They're very, very, very similar except for what's different.
The answer.
The b value. So whenever your slope is the same but your b value is different, what do you know about your lines? They're parallel. They're parallel lines. So 41, is that going to have a solution?
No.
No. 42. Are you going to have a fractional answer there? Or I should say a fractional expression that you plug in? Yes. Do you feel like you understand what I'm talking about with substitution versus elimination now? Okay, the rest of the period is yours to work on your homework. I'll have the answers up here so that you guys can come up and check as you go along. Any questions?
Yep.
Excellent. Yeah.